Now let's see this D5, branch and save written address. BSA means branch and save written address. So why is it used is, whenever you are trying to do this function calling, it will be useful. I'll just explain you how it is done. Assume that we have this program here. Let us say this is where the program is, and say you are at address 100, and now here you want to jump to the subroutine, and assume that the subroutine is starting at 200. Okay, now from here if you jump here to 200 and assume that this entire thing is the memory which is allocated for that subroutine, at the end, in the last instruction after this execution, you should have a return, and again you should come back and execute instruction number 101, right? So how can this be possible is, once you branch here, let us say if you are directly using this unconditional branch, once you branch to this address 200, there is no way you can again come back to 101 unless you save the written address, right? So when you are executing address number 100, program counter will automatically be containing 101, isn't it? Now we have to save that is nothing but the written address. So whenever you are executing an address, whatever program counter contains, that is nothing but the written address. Got it? So now this particular written address is nothing but the address to which we have to come back, right? Now this particular written address has to be saved at some place, and then we have to fetch it. The best way to implement functions, function call by saving the written address, is by memory stack. But then we are not going to use the memory stack and complicate the things. Instead, what we do is, we'll save the address in a fixed location in the memory, and then later we refer to that location to get the address back. So for that reason, every function call in our computer has to leave the first word blank, and this first word will be filled with the written address. So therefore this instruction, branch and save written address, before branching should save the written address 101 here, 101 here, right? And then it should go to 200, and after execution the last one should be unconditional branch to where? To 101. But then this is an instruction which is already written, so you cannot now load 101, because we don't know that we will be calling it from 100, or now we are calling it from 100, later we might call it from 200, maybe 300, right? Therefore we don't know where we call this function from, or there is a chance that we call it from multiple places. So there is no way I can type it hardware directly here. So what I do is branch unconditional 200. It means that the address to which you should branch is actually present in the address 200, which means it is using indirect address mode. Got it? So branch unconditional along with this indirect addressing mode will be useful as a return statement after the execution of the function call. So try to understand this one. Now there is a branch instruction here, which is nothing but a function call in this case. Now when you are branching to this particular address, you have to come back to the next instruction after you finish your subroutine. That is why we are trying to save the written address at some location, right? And later, by using a branch unconditional with indirect addressing mode, I can again get back to the written address. So let's see what has to happen here. Now how do I know that this instruction is branch and save the written address? If it is D5, right? And how do I know that it is the execution phase? If the clock is showing T4. So if it is T4, it means that we are trying to execute it. Now what are the various things that we have to do? One thing is, whatever is present in the program counter, if you are executing the instruction at 101, if this is BSA, right, BSA, let us say 200, which means I want to go to 200. This is what is the meaning of it. Now in this case, I have to save 101 onto this location, right? So what I should do is, this program counter has to be stored in the memory address, and this address 200 Either it can be direct address, right, or it can be indirectly we have got computed the effective address. Somehow, anyhow, T3 is going to be used in order to compute the effective address. So AR address register already contains the effective address, which is nothing but the beginning of the subroutine in this case, and at the beginning we are going to save this. That is why we are not going to have any code here. It is just left empty. Okay. Now by using this method without using a stack, we'll be able to do multiple function calls, which means you can call this function and this function can call some other function. But the problem here is, if some kind of recursion is used, direct recursion or indirect recursion, which means let us say A has called B, right? Now B will contain the return address of A, isn't it? B has called C, now C will contain the return address of B. Now in case if C calls B again, what happens? B has to now store the address of C, which is already storing the address of A, which will be overwritten and it will be lost. That is why recursion, either indirect or if B calls B, direct recursion. These two recursions, any type of recursion will not be possible if you are going to use this kind of scheme. So in our computer, I am assuming that any function will be called only once in a chain. It will not be called again and again. If it is going to be called again, the first function call has to return, then only it will be called. It is not going to be called in a chain two times. Under that assumption, we can use this simple organization. Since the computer is simple, we are going to design a simple computer. I'm going to go with that. Okay. Now see this. Now this program counter contains the return address, and that is now return address is now stored at the beginning of the required function. And the next one is I have to increment. Okay, when do you think that this one will happen? AC equal to PC contents, it has to be loaded into this, right? So if you see this, you are having a clock, and for that clock this is the time signal. Let us say T4 is high. T4 is high across this timing signal, right? Okay. Now when you are trying to load PC onto this, the contents of PC are always available, and anytime you select the multiplexer, the bus multiplexer, PC will immediately be available. Therefore PC can be kept on the bus anywhere in the beginning only, right? And again AR is already connected to memory bus, which means AR is also address is also available to the memory anywhere here, right? And so it can be done right away. You need not wait till the end of the clock, right? You need not wait till this point. You can do it as fast as the memory cycle. So this operation will get finished depending on how much time the memory cycle takes, which means what is the speed of the memory. Assume that memory cycle is very small compared to the clock cycle, right? In that case we can assume that it is going to be done fast, right? Now after that, what is the branch actually? Even though 200 is going to be the starting of the function, we are actually using this 200 to store the return address. We are not going to execute this. That is why program counter has to be now loaded with the 201, right? For that reason I am going to increment AR plus 1. So when will this AR plus 1 happen? So if you see this, AR address register is going to have an increment, right? So when an increment, it is also positive edge triggered, right? So when this particular control signal, when I give it 1, the increment is going to happen only at this point. By that time the present value of AR has already been used. Therefore I can put both these operations in the same cycle. Are you getting this? See, what I mean to say is, if you are having this clock like this, T4 like this, and if you are having the clock like this, right? So corresponding for this clock, this is the T4. Now I am saying that the access of memory using AR will be completed sooner, right? And the increment will happen here. So by writing both of them in the same clock, I'm not actually incrementing the register first. Even though I'm writing both of them simultaneously, incrementation will happen only at the positive edge, which will happen at the end of the clock, right, or at the end of T4. By that time the contents of PC are already moved into old value of AR in the memory. Got it? Okay. And now what should I do next? So after this one is done, I have to load PC with the new contents of AR. Can I write PC and AR here? Can I write this one, this operation here? I cannot write it, because if you do so, we are actually trying to do two things. What is it? We are trying to increment AR as well as load the contents of AR into PC, right? But then bus can be used only to contain one word throughout the clock, isn't it? Already throughout this clock, bus has been configured to get the contents from PC. Now if I try to put it there, now the bus has to be configured in order to read the contents of AR as well, but it is not possible there because already PC is present on the bus. I cannot put AR also on the bus. That is why I am putting it next. So what happens now? Now PR will contain 200. So with this instruction is over. So when this instruction is over, I have to start the next one, right? What is it? SC is 0. So when I do this SC equal to 0, then only the next instruction will begin. So next instruction will be at 201. Are you getting this? So initially when I am fetching this instruction, program counter will be 100, and then immediately after fetching this, the program counter will be incremented to 101, right? And now when I go, this 101 number is stored here, right? And it is again going to be changed to contain 201. Got it? So now that 201, which means here, now because of SC equal to 0, you will get the timing signal as T0, and we again enter into the fetch phase. And according to the fetch, whatever address is present in program counter, you have to go there and fetch. That is why execution will start from 201. Got it? Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%. But all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177, and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. and these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.